Hello folks, let's do a comparison between two hypervisors we have checked so far, ESXi and Hyper-V, and I'm not a salesperson, so I'm not going to try to sell you one of them. You decide which one is better if you want to pick one. I'm just going to list some important differences that I find useful to know, even from educational perspective. So you would want to know each of these specifics for each of them separately, and together it makes sense to compare these things. So I'm not going to say which one is better. There are different roles for different types of programs, and both of them are huge flagman products. But each of them has ups and downs, which we can review right now. So let's go. So at first, the operating system. On VMware ESXi, VMware uses its proprietary but Unix-like operating system called ESXi. I know of versions from 3.5 to 7.0 and some updates, so I haven't seen anything below 3.5 ever, and I don't think you can find it now. Before ESXi there used to be ES6 version, but generally most of them share the same command line, and typically you would want to use like Linux-like commands to operate this system. Hyper-V gets installed on top of Windows Server. It has appeared in version 2008 and has changed quite a lot in terms of new functionality, but the main functionality stays the same. So if you are a system administrator and you know how to operate a Windows Server, most of the settings, configurations and tools would be similar. ESXi clearly has Linux-like logs, like hostd, different daemons also would appear as logging there. We had a brief look at the folder with logs on the training for basic VMware stuff. Windows Server would only mostly rely on event, so you would check event viewer. This is where you could argue that ESXi is easier to troubleshoot and monitor because of more types of logs and deeper logging. And also each virtual machine has its own log in the ESXi, but in VMware you would probably struggle finding specific tools to troubleshoot or to monitor the environment which are not VMware itself. In Windows Server you can use all the different software packages for monitoring and troubleshooting that are common for Microsoft Windows. For example, all these internal tools, and there are a bunch of advanced tools which can replace the lack of logging in the server. The footprint in ESXi is very small, so it's only around 150 or less megabytes for system files. In Hyper-V, obviously, you have to install OS first. So even if you install the core version, it will still consume much more space. Right now, if I run my Windows 2019 with Hyper-V role, at least 25 gigabytes are taken by system only if I want to use the graphical interface with all the Windows features. The architecture below it is also quite different, which is obvious because the systems are developed by two different companies separately. So ESXi has VM kernel, which is the default kernel of the hypervisor, and then there is this UI service which runs like half graphical, half command line interface. There is also VM monitor management agents which run like daemons, and CIM system for monitoring. And Hyper-V runs its own hypervisor under the system. Then it has a root partition, which basically runs your virtual machine management service and the parent operating system of the host. And then you have child partition, which can be enlightened, which means it's host aware, or it can be unenlightened, so machines think they're physical servers, which runs guest machines. So both of them are type 1 hypervisors in terms of architecture. Even though you install Hyper-V on top of Windows, seemingly like type 2, Microsoft does a trick. So after you boot, it reconfigures the system and it puts the main operating system into the root partition of hypervisor. So even though you install Hyper-V as a role after you install Windows, it reconfigures itself to run before Windows. So it is still a type 1 hypervisor, bare metal one. When it comes to guest integration, in VMware you install VMware Tools package. It's delivered by VMware. You can do it from the console, and this is what allows you to communicate with the guest, and it allows you to basically check the IP address of the machine, see the DNS name, upload some files, control services. In Hyper-V, you use Hyper-V integration components, which serve the same role, but of course these are different Windows services. And finally, the ESXi and vCenter, which is a cluster structure, needs to store settings somewhere. So all the settings, information about VMs and about the configuration is stored in SQL database. It could be Microsoft SQL Server, it could be PostgreSQL, it could be Oracle. For Hyper-V, all the information is stored in Windows database itself, which is called WMI database, Windows Management Instrumentation. This is something that you can access by WBM test. So it's like a tool. If you type WBM test, this tool comes up, and you can also run queries like to SQL, but it's a completely different engine which comes together with Windows. So these are the first things that you would want to know about. The second, what if you want to cluster? Because you could have standalone ESXi servers, like separate physical computers, and you could have standalone physical Hyper-V servers. But it makes sense to put them in a cluster in most scenarios, especially because this way you can utilize the high availability feature. So the machines could be migrated from one physical server to another, and if you want to shut down one of them for maintenance, or if something bad happens, you could start up the same machines on a different server. So when you cluster, for VMware ESXi, you need to deploy a role called vCenter. It comes as a Linux image, so directly from the UI of ESXi web services, the vSphere UI, you can deploy a machine which has this role, and it comes by default as a Linux appliance, but you could also download and install the package of services to a Windows machine. So it depends on what you want to manage. If you want to manage the Windows machine, you would install it on top of Windows Server. So the vCenter server would be the role in the computer which stores the aforementioned SQL database. So standalone ESXi doesn't need a database server, but for vCenter you need to deploy database capable of SQL functions. So it could be Microsoft SQL, for example, in Linux if it's connected from a different machine. And if you want to keep it on the same machine, then you would have to suit it for the operating system. So if you want to keep vCenter with the database itself, for Windows version of vCenter you would have Microsoft SQL, either Express or full installation. And for Linux you would have PostgreSQL or Oracle database. For Hyper-V, for clustering purposes, you would rely on typical Microsoft failover clustering functionality. So you would use exactly the same settings you would use for typical Microsoft clusters. There is one more role you can deploy. It's called Service Console Virtual Manager, SCVMM. And this role can be deployed on another Windows machine, and then it can manage multiple clusters, multiple failover clusters. So you don't have to put everything in one cluster. You can create multiple clusters and then manage them through SCVMM. In vCenter, a role of these clusters would be called data center. So by default, it's integrated in vCenter. You could have different locations and then manage them all within vCenter. In Microsoft Hyper-V, you would have to basically set up a different machine for clustering purposes, for extra layer of clustering. If you want to configure your VMs, your virtual machines on local storage, in VMware, the most common option you would have is a serial attached storage, like a local disk, which is formatted for VMFS. Currently, version 5 is the most up-to-date. And for Windows, you would use typical Windows volumes, like what you have on your home PC if you have Windows installed, C, D, E, F, etc. And normally you would use NTFS file system. I have heard about people using the new ReFS file system, but I haven't tested it enough to have an opinion yet. I might make another video about running VMs on ReFS technology. If the storage would be external, this is where the differences start. So of course, in both cases you can use SAN, which means storage area network, so some kind of advanced box like HP or EMC or some other vendor could provide it. Then you could connect to it through iSCSI or through fiber channel. And of course there is option fiber channel over Ethernet, FCOE. But in both cases, the disks would appear like they are local in disk management, but they are actually on another device. So in both cases, you would present block level device, so it would be still VMFS for VMware, and it would be NTFS for Microsoft Hyper-V. However, one thing to mention that in Microsoft Hyper-V, you don't simply attach the volume through iSCSI. You also usually configure it as cluster share volume if you have clustering. So in Microsoft Failover Cluster, you have this CSV acronym when you connect SAN disk, and then you initialize it as volume and you attach it to C cluster storage. So that's a main point, and this is where typically you mount your cluster volumes for Hyper-V as well. You can also use file sharing protocol technologies to connect storage. For VMware, the most typical connection type would be NFS, so you could have NFS version 3 or 4.1 connected share, which is used as storage for your files for virtual machines. For Hyper-V, I don't know if people have managed to successfully use NFS for that. Theoretically, it could be possible, but normally you would use scale-out file server, which means SMB version 3 protocol. It's the same protocol that you use for normal Windows shares. And finally, if you don't take into account the web console or Hyper-V console where you control the machines, there are differences in the way you can access the machine from the host. So the most typical control and access action would be to open remote desktop connection or SSH, depending if it's a Windows or Linux machine. And that would be the same both in Hyper-V and VMware, because typically you're just using a remote desktop or SSH connection through TCP IP, through network connection on the IP. If you do not have this access, or if you don't want to use these, VMware also provides you a VIX or web services integrated with VIX method, which is API call method. You can have a command line which allows you to start, stop services in the guest, restart the machine, upload files, download files. So it's a fully integrated command line, but you need VMware Tools for that. So without VMware Tools, you would be unable to control the guest machine. In Hyper-V, you didn't have a similar API which you could use for network-less machines until recently. So in the newest versions, 16 and 19, you can use PowerShell Direct, but only if the guest machine is Windows, also version 16 or 19. So that's where PowerShell with Hyper-V integration tools together works like VIX worked with VMware Tools for VMware. So they are improving in this field. Now it is an option. You still cannot do that for Linux machines, unfortunately. Okay. And finally, let's look at the differences between virtual machines themselves. So the biggest win in this field, I feel like for Hyper-V, is that it uses GUID for virtual machine identification. Let me explain this. So the host, it could be ESXi or Hyper-V. In both cases, the host needs to know which machine is which. So if you want to reboot a machine, if you want to make a snapshot, if you want to download or delete the machine, then the Hyper-V and VMware needs to know which machine we are targeting. So for this purpose, the machines cannot be only reliant on the name. Somebody could change the name anytime and it would be a lot of confusion. So in both cases, there must be some kind of internal ID, internal identifier. In case of VMware, it's called MOREF, Managed Object Reference, and typically it's either just a number or VM-number. So if you are using standalone ESXi, it will be like 5, 13, 25. It's just a number basically. It says this machine number 20. If you would use vCenter, it would be VM-123, for example. So these numbers are given out automatically. So whenever you register a new machine or you create a new machine, this number will be incremented. So after VM5, you'll get VM6, VM7, and you cannot normally go back unless you hack into the database. Right? So there is a bit of a problem here. For example, if you made a machine, it got to reference 25, and then you decided to remove it, and then you recognize you need it again, so you restore it or you register it, it will get number 26. So if you work with backup applications or with some scripts, the scripts and backup applications targeting VM25 will no longer work. You need to change them to target VM26. So the backups would do full backups, some monitoring tools may need updates, so basically you cannot make it back 25. In Microsoft Hyper-V, the VM has a unique number called GUID, Globally Unique Identifier, and it has that format which is a common let's say, a format for numbers which we need to be unique. So it's this long sentence which is built using the same structure, 8-4-4-4.12, I think. Basically, each number is generated randomly from 0 to 9 and from A to F. So it's a hexadecimal number. There is a very low chance that by randomly generating such number, you get the same number twice. So this is a common ID type which is used for hardware components like BIOS identifier, and here it's used for VMs. And because it's supposed to be more or less unique, it's not like 25, which can be everywhere on any host. You can unregister and register the machine with the same ID again. So you can keep ID and all your old scripts, all your old backups will still work. So this is where Hyper-V obviously has some extra security because the ID is quite unique, and also it gives you more functionality. The files are quite similar in their role. So there are configuration files, memory files, disks, and checkpoints or snapshot files, but they are in different formats. So for VMware, you have VMX file, which is like a text file you can open, you can modify it. For Hyper-V, in the past, you used to have XML file for configuration. So you could open it and you can manually tweak it. Now in newer versions, it's binary, so it's compiled. You cannot directly modify it as a user. It's probably a good thing, but it makes it a bit harder to fix some, let's say, unexpected configuration failures. There is a swap file. In one case it's NVRAM, in another case it's binary file bin, but they serve the same role. They hold the swap of the memory of the machine. There are disk files, so VMDK for VMware and VHD or VHDX in the newer version for Hyper-V. Again, different formats, same idea. Now, when it comes to snapshots, there is a difference. So in case of VMware, it also makes VMDK, which is similar to normal VMDK. In case of Hyper-V, it makes a VHDX, which is a growing checkpoint, and I'll explain the difference shortly. And also in case of VMware, you have a vmware.log, the file of the log of the machine, which makes it possible to directly check separate log of each machine without going to global events or setting up some monitoring tools. And if we're talking about snapshots, the VMware uses copy and write method. So it stops updating the disk of the machine, it starts writing into the delta file which is created. In Hyper-V, it uses redirect and write internally, and externally it also writes to checkpoint. So there are actually two snapshots when you do Hyper-V backup. There is a snapshot on the host level, and there is a snapshot in the guest, which can be turned off. It's called then offline backup, but I'll make another video about that. In Hyper-V, actually, what's better, I would say, is that it has auto recovery and guest volume shadow copy integrated into the snapshot. So whenever you take a snapshot in VMware, by default, the guest will not know about the snapshot unless you use QoS feature, which requires VMware Tools and which also is integrated with DSS technology somehow. In Hyper-V, the whole process is streamlined. So whenever you start taking a snapshot on the host, it takes a small break to make a snapshot on the guest, and when the snapshot on the guest is finished, it will go back to the host, roll back the changes, and then finish the snapshot. So the snapshot will have a consistent state regardless of the fact that it's done in two places. And this is called auto recovery phase. That calls for a separate article and video how does auto recovery work. But basically, this is fully integrated in Microsoft Volume Shadow Copy and Backup, and this is why you could consider this to be a bit more consistent, even though you could use backup tools which use the same functionality in both cases. Finally, I would like to add that even though technologies are different and logs are different, the approach to administration, management, and troubleshooting is still the same. You just need to know the specific tools you can apply to test performance, to troubleshoot errors. You need to know which logs or events to check, and you need to know how the technology works in the background if you want to build a detailed step-by-step plan for the setup or for troubleshooting. That should be it for the brief video about the differences. I'm going to look forward to the comments. If you want to add something, I can add an extra part if you find that's important, and I'll be happy to see you in the next video. If you have watched so far, leave a like, subscribe if you want to see more content like this, and have a good day. Bye bye.